Hello everyone, welcome to our channel Everyday Learning. So in today's video of digital logic design, we are going to learn about encoders. So an encoder accepts an active level on one of its inputs and converts it to a coded output. For example, a decimal to BCD. So consider this is an encoder and the encoder takes decimal inputs. So we give like 0 to 16 decimal inputs, and it will be able to produce 4 outputs. For example, BCD outputs. So if you see on the table that is given on the right side of my screen, we have the decimal inputs here, decimal inputs 0 to 9, and the encoder will be able to produce BCD outputs. So whenever we give 0, we'll get 0 0 0 0 output from our encoder. Whenever we give decimal 1 input, then we'll be able to get 0 0 0 1 as the output sequence, and in this pattern we will get the subsequent binary output for any of its decimal input. So encoder acts like opposite to that of a decoder, opposite to a decoder. So it takes in a bunch of inputs and can produce a sequence of output through its process. So if you can see here, you can find out a sequence. For example, let us see for A. In case of A, you can see that A gives output of 1 and 1 only in case of 8 plus 9. So whenever the encoder is supplied with input 8 and 9, its A will give output 1. So moving on to number B, or the output B, so it will give one output for 4 plus 5 plus 6 plus 7. In this way, let us see for C. So we have this sequence for C. So C is equals to 2 plus 3 plus 6 plus 7. And finally, for D, we have 1 plus 3 plus 5 plus 7 plus 9. So as you can see, if you want to design the encoder circuit, you will need these logic sequences. So whenever these logic sequences are implemented, then the encoder can be designed. For example, let me show you. Let's take at first for 1 0 1 2 3 4 5 6 7 8 and 9. So let's do first for A. A is 8 plus 9, so we pull input from 8 and 9 and we include an OR gate, and we have our sequence A ready. So for B, we have 4 plus 5 plus 6 plus 7, 4 5 6 and 7. So if we include all of these using an OR gate, so this will be our sequence B. If we look at C, we have 2 3 6 7, 2 3 6 and 7. Including all these with an OR gate, we have C, and for D we have 1 3 5 7 9. 1 3 5 7 and 9. So this is our D. So in this manner, we have developed the four output sequences A, B, C, D. So this is our decimal to BCD encoder. With this one, you can produce a pattern of BCD outputs from given decimal inputs. So I hope you understood using this example how an encoder functions or how an encoder can be used in a circuit. If you have anything else to mention or know about, let us know through the comments and we'll get back to you. And thank you for watching our video.